So we reached the topic of hash maps, and we are inside exercises, hash maps 1. So let's go into it directly. A basket of fruits in the form of a hash map needs to be defined. The key represents the name of the fruit and the value represents how many of that particular fruit is in the basket. You have to put at least 3 different types of fruits, for example, apple, banana, mango, in the basket, and the total count of all the fruits should be at least 5. So we have to put in 3 different types, and each value of these types or the amount of these types should exceed 5 or be at least 5. All right, and as you can see here on line 15, we are importing hash map from the standard library in the collections module. So we imported that using an use statement. We have covered that. And as you can see in the function fruit basket, we are returning a hash map. And as you can see, it returns a hash map of keys with type string and values with a type of unsigned integer. So basically, you can imagine a hash map if you're familiar, for example, with Python or JavaScript, like a dictionary, and you have here your keys and your value pairs, like that, key value, and so on. And this is really good for querying data. For queries, you can search pretty fast with hash maps. It's a data structure and it's basically implemented in Rust. In C, you have to basically build it up yourself, so that's great. And as you can see here, hash map has type string keys and unsigned integer values. So for example, this is a string and it will hold an unsigned integer, another string, and like that. Because it's unsigned over here, we can make it negative, that's no problem. And of course, this is just for representation. In fact, you won't see it like that in a Rust program. It's not implemented like that, I guess, but it's just that you can imagine what we are talking about here. And yeah, so here we have our first to do, declare your hash map here. So it's basically pretty simple. We declare a hash map like that. We call hash map and then the new function. And what we also can do over here, we can annotate the type. So for example, we can make that string unsigned integer. And the type annotation is not really necessary here, but just for clarity's sake. So 2 bananas are already given for you. And as you can see, this is the syntax for inserting keys and values in a hash map. So as you can see, we have here a variable which is mutable called basket. We are accessing that and call insert on it, and then we will pass the key, which is in here a string. And of course, because this is an actual string or a string object, we have to convert the string slice over here to an actual string. If you watched my course on strings, you will get what I mean. So basically, we are not returning a string slice, we are returning a string. And then we are passing the value, the unsigned integer value of 2. So to do, put more fruits in your basket here. So in fact, I will basically just copy that one 2 times, and yeah, we can then, for example, put apples in it, and I will put 4 apples, and I will put lemon, let's do 3, like that. Let's see. Then of course, as you can see, we are returning the basket, and it's compiling. And just so you see, what we basically have here is we have a hash map banana 2, so we have a string banana with a value of 2, we have apple with a value of 4, and we have lemon with a value of 3, like that. As I've said, you won't see it in a Rust program represented like that, but just that you have an idea. All right, let's go to the next one. Hashmaps 2. And I will do it like that. A basket of fruits in the form of a hash map is given. The key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. You have to put more than 11 fruits in the basket. 3 types of fruits: apple 4, mango 2, and lychee 5. I'm hoping that I am pronouncing that correctly. I have no idea what's that. Are already given in the basket. You are not allowed to insert any more of these fruits. Make me pass the test. Again, as you can see, we are importing a hash map, and here we have an enum of name fruit, and basically here we have our fruit members of the enum, and again we have a function fruit basket. It expects an argument basket, which is a hash map with fruit keys. So the keys will be of type fruit, which is an enum, so it will have one of these values, and a value of unsigned integer. And of course, this hash map is a mutable reference. All right. Now, here we have a vector, which basically just holds all the members of the fruit enum, and it stores it inside the variable fruit count. So this will hold a vector with fruit types, and then we are iterating. We have a for loop for fruit in fruit kinds, that's this one, and it's basically just iterating over all these enum members and put new fruits if not already present. Note that you are not allowed to put any type of fruit that's already present. So as you can see, we already have these fruits inside the hash map: apple 4, mango 2, and lychee 5. So let's see. This is what's inside the basket. Right. Now, as it says here, put new fruits if not already present. So some values over here are already inside the hash map, so we cannot put it in another time or again. We have to filter out basically if it's already in there or not. So in the first iteration, fruit will hold the value fruit apple. Fruit apple is already present. As you can see here, it's already inside with a value of 4. So first thing, we will access the basket. That's actually the hash map. And then there is a function entry. And this function, or better, this method, allows us to pass a value, for example fruit, and fruit in the first iteration of the loop will be fruit apple. So it's basically the same as we would type here fruit apple, and then entry will basically say that this is already inside, or it's already occupied. And what we then can do is basically, if it's already inside, we will do nothing. We won't insert anything or modify anything. But for example, in the second iteration of the for loop, fruit banana is not inside there. So we have to specify what we will do if there is no entry for fruit banana. And this is accomplished with or insert, and then we can give it a value. So for example 3, and all this does is really, it checks first basket, checks if there is fruit banana, and of course it's not. And then what it does, or insert, it will then insert an entry in the hash map, which then basically is like that, fruit banana, and it will hold a value of 3. So this entry will get passed to the hash map. Of course, not in this form with the curly braces or something like that. It's not like that, but just that you can imagine what's going on. All right, let's see. And it's compiling. So if we are iterating over this vector, and if there is actually an entry for any of these, nothing will happen. It will just go to the next iteration, and if there is no entry, it will insert the key, which will be one of these, and it will insert the value, which will be 3. So in the end, just so you see what I mean, we will have, for example, fruit apple, and this will hold 4, I guess. Then we have fruit banana, which will hold 3 because we passed 3 over here. Then it goes to fruit mango, and mango is already there, so it has a value of 2, and so on. I hope you will get the idea. And yeah, that's basically it. All right, the last one. A list of scores, 1 per line, of a soccer match is given. Each line is of form Team 1 name, Team 2 name, Team 1 goals, Team 2 goals. Example, England, France 4-2. This means England scored 4 goals, France 2. You have to build a scores table containing the name of the team, goals the team scored, and goals the team conceded. One approach to build the scores table is to use a hash map. The solution is partially written to use a hash map. Complete it to pass the test. Make me pass the tests. Alright, again, first thing, it's the hash map gets imported from the standard library collections module. Then we have a struct over here, team, and it holds a name of type string, goals scored of type unsigned integer, and goals conceded of type unsigned integer. Over here we have a function build scores table. Results will be of type string. So this argument that gets passed is of type string, and we basically return, or we transform that into a hash map with string keys and team values. And team values means a value that is of type struct team, like that. All right, the name of the team is the key, and its associated struct is the value. As you can see, here we have a new hash map created, and it's stored in a mutable variable scores, which holds a hash map with string keys and team values. Right, then here we have a for loop, and it iterates over results dot lines. And I guess, all right, it's actually declared here results, and here what we basically have is a string slice. It gets converted to a real string, and then just these get appended. So we have here string, and that's actually the one from the example, England, France 4-2. This is a new line character, so this basically will go one down, like you would click or press on your enter button. This is a new line symbol. France, Italy, Poland, Spain. All right, that's it. And this will then get passed, as you can see here, build scores table, and this will get passed. So the string over here, this is of type string, will get passed in the results. And then we are basically iterating over each line, and R holds one line at a time at each iteration. So we have an iteration. In the first iteration, this is R, then R holds this line, then this line, and then this line. Then R will get splitted up on the commas and then be collected in a vector. And basically, as you can see, it gets past England, France for 2, and it's separated with commas. And what this split does is basically just put these and this and this and this in its own form, and then collect will put it in a vector. So what we will end up getting is something like that. So we have England, we have France, and we have 4, and we have 2, I guess. Let me see. 4, 2. Okay. And just to make something clear, these are strings. They are surrounded in double quotes because we are here in fact passing a string, and then it gets split up and put into a vector. So every element of the vector will hold strings, because a vector, as you might remember, can only hold types, or can only hold the same types. It can't hold integers and strings. It has to be either integers or all strings, and in this case it's strings. Then, and of course here it's not a string, it's a string slice. Please refer to the strings course I have made, so you will get what this means. And this is basically also the reason we access here the first element and put it into a string. So this will actually hold a string and not a string slice, just for clarity. And also here, string. And as you can see, we store it in team1 name, and then we access the third element. As you remember, vectors have index 0, so 0, 1, 2 is the third element, and it will get parsed. And what parsing actually is doing is basically it takes this string and puts it into an integer like that. And unwrap is for error handling, but we will cover that later. And this will get stored in team1 score. So 4 is the score of England and 2 is the score of France. And over here the same thing, we get index 1 France, put it into a string, team2 name, and here the same thing. We have 2 and we put it, or we convert it to an integer like that. All right, now we have these variables. To do, populate the scores table with details extracted from the current line. Keep in mind that goals scored by team 1 will be number of goals conceded from team 2. And similarly, goals scored by team 2 will be the number of goals conceded by team 1. So what this basically says is England scored 4 goals against France and conceded 2 goals. Because, as you might remember, here in the team struct, we have, for example, name will be England we have goals scored, which will be 4, for example, and goals conceded in this case will be 2. So that's just for clarity. And as I've said, this is only an example for the first line. This is the first line, but we are iterating over every line one at a time. So R always holds one line. All right, so I know basically 2 ways of solving that. The first one is the old school way, let's say. So what you will do is make 2 variables, team1 and team2. Now let's start with team1 and we will access the results. And so the results is basically the argument that gets passed over here. Or, excuse me, not the results, we access the scores. Because this is actually the hash map we want to modify. So we access the scores. And first of all, we check if there is an entry already inside this hash map for a team1 name. And let me see something. Okay, I just got a message. I had to reply. Sorry. So we have here, we check, is there already an entry for team1 name? In this case, England. And of course it's not. It's the first iteration. We don't have anything in there. And then we basically make or insert with key. And this is a function, and I've opened it over here. So let me see, how can I zoom in here? Like that. This will basically, as you can see here, we have a hash map of string size keys and usize values. We have stored it into variable map, which is mutable. And then we check, is there an entry with Ponyland? And if there is not, this will get called or insert with key. And key here, this is a closure, and this parameter will basically capture this variable. And then it takes key, which is in this case a string slice, Ponyland. It takes the chars, this will return an iterator, and then count. It basically counts how many characters there are. This will then be put as the value of this key. So we have then in map, we have Ponyland, and this will hold the value of 9. And also, this will return a mutable reference to the value. So a mutable reference to 9 in this example. This is the return value of this. So, or insert with key, so we capture the team. This is what we will capture, team1 name. And then all we basically have to do is just make up the struct. So we, of course, this is now in case there is no England in Hashmap. which there is not. It's the first iteration. So we will just make a new instance of the struct team. Name will be team. Goals scored will be 0, and goals conceded will be 0. So that's it. And then we basically just can access team1 dot goals scored, and we can increment it by this value, team1 score. And then we can make goals conceded. So let's see, goals conceded, and this will be team2 score, as we've said, because we are here now in England. Team1 will be England over here. So we have in goals scored, we will increment it by team1 score, which holds this value, and goals conceded, we will increment it by team2 score, which holds this value. All right, and of course, in the same iteration, we will do the same for team2. So in this case, France. And again, we will access the hash map. We will check, is there an entry for team2 name, which in this case would be France. If there is not, or insert with key, again, team will be the parameter of the closure, and we will make team, and name will be team. This is what will be captured, team2 name. Goals scored will be 0 in the beginning, and goals conceded will be 0. So, and same thing, team2 goals scored will be incremented, and this time team2 score, because we are now checking team2 France, and France has this value for team2 score holds 2. This is the amount of goals scored by team2. And again, team2 goals conceded will have team1 score. Same logic, France has conceded 4 goals of England. And then what we do is we will return scores. That's it. That's the hash map. All right. Let's see. All right. Okay. Now the mistake over here is actually because this is a reference of string, and we want to have a string. So what we'll do here is just do that string from team like that, and here the same thing. So string from team. And as you can see, it's compiling. So the mistake here was that actually here a reference gets captured, and we basically have to make it a string, because as you can see in the struct, it's a string and not a reference of a string. So that's actually the first method, and this is working fine. But there is actually another method that is even a little bit better, because as you can see, we are checking here in scores, is there an entry of team 1 name? If there is not, we will basically create an instance of team and we will initiate it with 0 values and then basically increment it with the goals scored and goals conceded. But what we actually can do, we can delete that, or you know what, I will uncomment it, so we will then basically find it and you will see what the difference is. So instead of doing it like that, we can basically delete that one because we don't need it anymore. So we don't need this, and we can use here and modify, and that's a method for hash maps, and what it does, provides in place mutable access to an occupied entry before any potential inserts into the map. As you can see, we have an empty hash map of string slice types and unsigned integer values inside map, which is mutable. Then we check, is there an entry Ponyland? If there is, we modify the value of the hash map and we will just increment it by 1. If there is not, we will insert this entry Ponyland with a value of 41. That's what you can see here. We have Ponyland 40, excuse me, not 41, 42. So we have Ponyland with a value of 42. Then again, we call the same thing, map entry Ponyland, and of course this time we have it inside there. Ponyland is inside the hash map, as you can see here, and then actually this will get executed. So E here is the entry and it just gets incremented by 1. As you can see here, this is the end result. We have an entry in the hash map, Ponyland, which has the value of 43. And yeah, we can pass here a closure, score, and what we then can do, or I will make it just entry, we can then basically entry dot goals scored, and we will do it like that. Team 1 score, and then entry dot goals conceded, and we will increment it by team 2 score. And then if there is not an entry inside it already, we can actually initiate it with the value. So team 1 score and team 2 score. because this won't get executed if there is no entry. So we can actually start right with the score. So in the first iteration over here, England has no entry, so it will get actually here initiated. The struct team will get an instance, and we can directly pass these scores. And I will do the same thing over here. So like that. Let me comment out this first so we don't forget it. And the same thing basically. Entry team 1, and then and modify. We have entry, and then basically for entry goals scored, we increment it by team to score, and then entry goals conceded, team 1 score. Same logic. And over here too, so we can team 2 score and team 1 score, like that. And let's see if it's actually compiling. And it's compiling, as you can see. So I think this one is a little bit cleaner than this one, but of course you can choose whatever you wish. This is the old school way. I think we have a specific method for this, and it's just nice because if there is an entry, it will get modified directly. If there is none, then it will get initiated with the actual values. So that's pretty nice. And there was one thing I guess I forgot to mention, but yeah, and modify basically, as you can see here, will just return self. And over here in the closure, it is callable only once, and it basically has mutable reference to the value. So this is a mutable reference to the value, like that. And I guess what we also can do here is like that, but I'm not sure. So no, type here cannot be the reference. So it's already dereferenced. So forget about that. All right, this is fine, I guess. And yeah, we have made it compiled. So I will just show you pretty quick what you will get over here. For example, here we have then England, and this will hold a struct, and basically name will hold England, goals scored will hold, and I'm just talking of the first iteration here, will hold 4, and goals conceded will hold 2, you know, and then team 2 will be the same. So we have then France, and this will then hold name, France. This will then hold, as you can see, it's here. Let me just do it like that. France will then hold name France. Goals scored will be 2 and goals conceded will be 4. And you know, it's iterating over each of them, and then when it basically finds another one, for example, England over here has 1, so this will actually get modified, so goals scored will be 5 and goals conceded will be 4, like that. And for the other values it will be the same. So I hope you get what this is all about. This was the topic of hash maps, and the next topic, I guess, let me just see what will be the next topic, will be another quiz. So see you then.